Today's lesson, silicon tetrachloride is hydrolyzed, but carbon tetrachloride is not hydrolyzed. Why? First of all, let's try to know why this question arose. We can get the answer of this question from the positions of carbon and silicon in the periodic table. Let's see positions of carbon and silicon in the periodic table. Carbon and silicon belong to column 14. Carbon, silicon, germanium, tin, lead, ferrovium. Carbon with chlorine forms carbon tetrachloride. Silicon with chlorine forms silicon tetrachloride. We know elements of a particular column have same valence electrons and same valency and hence same chemical properties. Considering this point, carbon tetrachloride and silicon tetrachloride should be same in chemical properties, but silicon tetrachloride is hydrolyzed, carbon tetrachloride is not hydrolyzed. This is today's lesson. We are going to learn the reason behind this. Let's go to the detail. The very first point is hydration or hydration reaction. Let's see the reaction. Hydration or hydration reaction. Let's see an example first. When sodium chloride is dissolved in water, then in water sodium chloride is ionized as sodium ion and chloride ion. This sodium ion is surrounded by negative pole of water molecule in this way. Oxygen is negatively charged and sodium is positively charged. There is attraction, that means water molecules attach to sodium ion. Similarly, positive end of water surrounds chloride ion. Here also water molecules attach to the chloride ion. Here no bonds of water molecules break. Only water molecules adhere to sodium ion and chloride ion. Water molecules remain intact. This kind of reaction is called hydration reaction. The reaction where water molecules do not undergo breaking of bonds. Let's see another reaction. When copper sulfate is dissolved in water, then copper sulfate pentahydrate is formed in this way. Copper sulfate, 5 molecules of water, then copper sulfate pentahydrate is formed. Here as well, water molecules just attach to the copper sulfate. No breaking of bonds of water molecule occurs. Let's see how 5 molecules of water attach to copper sulfate. Copper 2 plus, this is water molecule. Oxygen of water molecule forms coordinate covalent bond with copper 2 plus ion. Another water molecule forms coordinate covalent bond. Another water molecule coordinate covalent bond, another water molecule, coordinate covalent bond. Here already 5 molecules of water are accommodated. Then sulfate ion, this is sulfate ion, another molecule of water. This is positively charged hydrogen ion, positively charged hydrogen ion. There is an attraction here. This hydrogen is positively charged, this hydrogen as well positively charged, and this oxygen is negatively charged. So here there is an attraction. Now we see that 1, 2, 3, 4, 5 molecules of water are accommodated in copper sulfate. Here 5 molecules of water adhere to copper 2+ ion and sulfate ion. No breaking of bonds of water occurs. So the reaction in which one or more molecules of water attach to ionic compounds to form crystal lattice without breaking of bonds of water molecules. This kind of reactions are called hydration reactions. Now let's move on to the next point. Now the point is hydrolysis or hydrolysis reaction. Let's see. Hydrolysis or hydrolysis reaction. An example, when aluminum chloride is added to water, then aluminum hydroxide and hydrochloric acid are formed. In this reaction, bond of water molecule breaks, and then aluminum hydroxide and hydrochloric acid are formed. Breaking happens in this way. This is water. From water, breaking this bond, hydrogen ion and hydroxide ion are formed. Aluminum chloride produces chloride ion. At the same time, aluminum 3+ ion. Chloride ion combines with hydrogen ion to form hydrochloric acid, and aluminum ion combining with hydroxide ion forms aluminum hydroxide. So in this reaction we see that water molecule undergoes breaking of bonds. The definition is the reaction in which water participates in chemical reaction, and as a result water molecules undergo breaking of bonds to form products. This kind of reactions are called hydrolysis or hydrolysis reactions. Hydro means water, lysis means breaking of bonds. So hydrolysis means breaking of bonds of water molecule during chemical reaction. This kind of reactions are called hydrolysis reactions. Let's move on to the next point. Now the point is hydrolysis of silicon tetrachloride. Let's see. Silicon tetrachloride. First of all, we see electronic configuration of silicon. Silicon 14, 1s2, 2s2, 2p6. Up to 2p orbital, 10 electrons have been arranged. Another 4 electrons enter third orbit. Third orbit contains 3s orbital, 3p orbital and 3d orbital. Silicon has remaining 4 electrons. Out of these 4 electrons, 2 electrons enter s orbital and remaining 2 electrons enter p orbital, but d orbital remain vacant. This is the point to be discussed. That means d orbitals of silicon remain vacant. Now let's see hydrolysis of silicon tetrachloride. Silicon, chlorine, chlorine, another chlorine, another chlorine. Let's consider this is d orbital of silicon which is vacant. Here water molecule. Oxygen has 2 lone pairs of electrons. Oxygen using 1 pair of electrons forms coordinate covalent bond with this vacant d orbital of silicon, and this compound is formed. Silicon, chlorine, chlorine, chlorine. Here oxygen, hydrogen, hydrogen. As oxygen donates electrons to silicon, here positive charge is developed and silicon obtains negative charge because silicon received electrons and oxygen donated electrons. Now because of this positive charge, these electrons move towards oxygen, and at the same time this chlorine removes with these electrons as chloride ion here, and here this is hydrogen ion. Chloride ion and hydrogen ion forms hydrogen chloride, and here compound of silicon is formed, that is silicon, OH, chlorine here, chlorine and another chlorine. In this way chlorine atom is replaced by hydroxide ion. That means here breaking of bond of water molecule occurs. So silicon tetrachloride undergoes hydrolysis because of the presence of vacant d orbitals, and in this way all the 3 chlorine atoms are replaced, and then this compound is formed, silicon tetrahydroxide. That means H4 SiO4, which is known as orthosilicic acid. This is all about hydrolysis of silicon tetrachloride. Let's move on to the next point. Now the point is hydrolysis of carbon tetrachloride. Let's see. First of all, let's see electronic configuration of carbon. Carbon 6. 1s2, 2s2, 2p2. The outermost shell of carbon is second shell. Second shell contains s and p subshells. So here no d orbitals. That is, silicon contains vacant d orbitals, but carbon has no vacant d orbitals. Let's see the reason behind not occurring hydrolysis of carbon tetrachloride. This is carbon, chlorine, 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 another chlorine. In case of silicon, there was vacant d orbital with which oxygen formed coordinate covalent bond. But in case of carbon, no vacant d orbital, no formation of coordinate covalent bond, and no reaction happens. That is, silicon has vacant d orbitals. Because of the presence of vacant d orbitals, silicon tetrachloride undergoes hydrolysis reaction. But in carbon tetrachloride, carbon has no vacant d orbitals. That is why carbon tetrachloride doesn't undergo hydrolysis reaction. This is all about hydrolysis of silicon tetrachloride and carbon tetrachloride. No more today. Thank you very much.